Hey, it's Greg over here at Dention. Often we're helping labs swap out spindles remotely, so we want to make a quick video on how to do that. First, you'll need a mill that needs a spindle, and then you'll need a spindle. If it's a newer 52D Plus, it's going to use the ZS52D spindle replacement kit. If it's a legacy machine, which most of them are, it's a ZS4D spindle replacement kit. In addition to these, you're going to need a single tool. They make it real nice and easy for us. So if you're not sure which spindle you have, you can check visually. If you look down at the bottom of your spindle, the ZS52D has all these holes around the bottom. It's actually a balancing feature. And then the older legacy spindle doesn't have those. So this is the ZS4D and this is the ZS52D. All right, we'll get started here. So we're gonna jump into the vPanel and we're gonna go to the maintenance icon, which is a little wrench and the hammer. And then we're going to go to the maintenance tab, and then we're going to go to the spindle replacement option and hit OK. And what that's going to do is it's going to present the spindle to you. So the machine will move to a position where the spindle is accessible for you to do the work. With the spindle in the spindle change position, we'll just talk about what we're looking at here. Right here on the right side is your spindle drive motor and its mount, and then you have the spindle itself, and they're connected to each other with a belt. The spindle drive motor rides on a mount that is pre-tensioned by this spring. So the first step is to reduce the tension on the belt so that we can take it off. And in order to do that, we're going to loosen, not remove, the 3 screws that hold this to the spindle head. You know which screws they are because they're in slots. So you have one here, so 2 on the right, and then you have one here, 1 on the left. What we'll do is we'll unscrew those. Now I'll do what I said I would do. And they don't need to be taken out. You just need to loosen them maybe 2 turns. And with those loose, you'll now be able to push this and it'll be mobile. But you can see that the spring actually keeps tension on the belt. So I drop the belt off, the belt's no longer in my way. Okay, so the next thing we're going to do is we're going to take the old spindle off. And here we have 4 screws. They're going to come all the way out. And don't worry, the spindle will not fall. It's actually held on the back side with some pins. So we'll take that out, set it aside. Okay, so you got your screws out. And as you can see, the spindle hasn't fallen. And we're just going to grab it and just kind of give it a little gentle wiggle as we're pulling off, and it'll come right off. And the belt will come with it. Now these are the pins, the holes for the pins, and those are the pins that hold it on and give it alignment. Okay, so this is an important precision mating surface, so I do like to make sure that it's clean. And then we're also, while we're in here, some of the older machines, these pins will get pushed in and they'll just be little tiny nubs. If your pins are nubs, you need to stop and you need to call your dealer. Don't try to grab these out with the pliers. You'll end up making yourself a big mess. But we just want to be aware of that and make sure things are clean and beautiful and nice. No dust, no fingerprints. Okay, so now we're going to put our new spindle in. And we found that the easiest way to do this and manage the belt is to put the belt on top and give it like a little 90-degree turn like this. That way it's already routed in there and you don't have to try to squeeze it through a really tight area after the spindle's mounted. So we come in, we're just going to hold this thing and feel for the alignment of those spring pins and then just gently push it on there. And then we'll take the belt and just like a bicycle chain, if you've ever done a bicycle chain, we're just going to stick it on there and then gently roll it. Now, you might be concerned that this is not straight. And that's a natural concern, but one of the genius things behind the way this is designed is that it will self-center as soon as it turns. So here, watch this. We'll turn it, and you watch that belt, and it's going to find its happy center place all by itself. Belt's on, spindle is kind of stuck in its position on its pin. Now we're going to reinstall our screws. What I like to do is just throw them all in. And one of the big rules of assembly is that any time that you have more than one screw in any sort of assembly, you always get all of them threaded before you tighten. So what we're going to do here is just thread them. I'm not trying to put any tightness on them. And the reason you do that is because if there's any sort of misalignment and you've tightened one of them, you've locked in that misalignment and then the other screws won't align. And that's how you get cross-threaded stripped hardware, which, by the way, is a complete nightmare in this situation. And it's an expensive nightmare. So we're not going to be stripping hardware here. So we're all screwed in, threaded, and now we're going to run them all down until they stop. I'm still not tightening them. I'm just going to go down. I'm going to bottom them out. And this is assuring that we get a nice even pressure that when we're applying these screws. So they are now all bottomed out. Now we'll go through and tighten them. Now, these are small screws. They don't need to be lug nut tight. We're just going to get on one, and I'm going to give it about a quarter turn, and then I'm going to go diagonal. Give that one a quarter turn. Give that one a quarter turn. Give that one a quarter turn. Now we're safe, we're good, the spindle's happy. Okay, so the spindle part of it is installed. Now we need to make sure the belt is properly tensioned. So this spring applies exactly the perfect amount of tension for the belt. Please fight the urge to make it tighter. If you make it tighter, you put load on the bearing in the top of the spindle here that it's not designed to take, and you will destroy your spindle and shorten its life. So we want the spring to do its work. And just to make sure it's not binding, I just usually give this a little bit of a wiggle. That's all it takes. It's in a neutral position where it has the appropriate amount of tension. Once it's in that neutral position, all we're going to do is go back to those same screws that are in their slots, and we're going to go down on all three of them until they stop. That's going to seat the mount against the plate that it's attached to, if I could see. So they've just gone to stop. And then we'll go ahead and do that little snug up. Not quite a quarter turn on these, it's more like an eighth turn. I'm just snugging it where I can just barely feel the screwdriver kind of start to twist a little bit. That's all it takes. And then I like to give it a little spin for good measure. All right, and then we're gonna go back to V-panel. So we'll shut this guy up. We're super happy with the physicality on the machine. Okay, so we're back at V-panel here. And what we're going to do is, first off, you always want to reset your spindle time. Now, this demo machine here only has 71 hours on the spindle. We're not going to reset it. But the reason why we hit this reset button is to zero it out so the machine can track the amount of time on that spindle. And that's really important for, one, getting the most life out of your new spindle investment, and two, in a troubleshooting situation, we're going to go in and look at the logs on the machine and know how much time's on the spindle, and that's going to dictate the direction we're going to go with a troubleshooting or diagnostic process. So don't ever forget to go back in there and hit reset and zero out that spindle work time. Once we're done there, we're going to go ahead and let the machine do a spindle run-in. What is a spindle run-in? Spindle run-in, we're just going to run the spindle up through its full RPM range, slowly and gently, and that heats it up and distributes the lubrication that's inside the bearings and makes it happy. It's like a little mini warm-up break-in period. So that icon's right here. We'll go ahead and do that, and we'll go ahead and let the thing do its thing. Takes about 20 minutes. We'll come back in 20 minutes. All right, now that it's been 20 minutes and the spindle's warmed up, we're going to go ahead and just do an automatic calibration, which it's something we like to do anytime the machine is disturbed physically, and that includes replacing the spindle, because there can be minute differences in the way the spindle's mounted or aligned. So we always want to recalibrate so that we can zero back all those reference points for the machine to run accurately. So we're going to take this, stick it on in the C-clamp, do the patented Dention wiggle test. Jump back into V-panel, hammer and wrench, maintenance, automatic correction, read and pay attention to the prompts, let her rip. Wait another 20 minutes. All right, all done, ready to go. We're going to take our calibration object out, And now we can go ahead and run it and enjoy the beautiful milling results from a nice new spindle. And if you like this type of thing, we plan on continuing to put a lot of this sort of content out. This is only the beginning. There's a lot of kind of deep, interesting knowledge things that we're planning on sharing here. So definitely make sure that you're following and liking and sticking with us here, because there's always more to come.